Hey guys, today we're going to review Unit 11, which was all about polar and parametric equations. So jumping right in, this first set of questions asks to convert each set of polar coordinates into rectangular coordinates. So what we're being asked to do here is polar coordinates are in the form r comma theta. They want us to convert this into x comma y. Each variable has its own little equation to go with it. If you want to find x, that's just going to be r times cosine of theta. And if you want to find y, that's r times the sine of theta. Okay, so let's look at this very first one. It's 2 comma 5 pi over 3. So 2 is our r, and 5 pi over 3 is theta. So if I wanted to find x, I would do 2 times cosine of 5 pi over 3. So this would be 2 times, cosine 5 pi over 3 is on the unit circle. So I'm looking at it right now, and cosine of 5 pi over 3 is 1/2. So this is kind of a simple one. The 2's cancel out, and all I'm left with is just 1. So x is 1. To find y, 2 times the sine of 5 pi over 3. Again, I can find this on a unit circle, so it's going to be 2 times sine of 5 pi over 3 is negative square root of 3 over 2. Again, this is pretty straightforward. The 2's cancel out, and all that's left is that negative square root of 3. So if this is x and this is y, to write our coordinate in rectangular form, we just put them together. 1 comma negative square root of 3. Okay, let's look at another one. This one, -6, -7 pi over 4. So this is r, this is theta. So I'm kind of looking ahead, and it would be nice if this would be on the unit circle, -7 pi over 4. Now, +7 pi over 4 is on the unit circle, but the issue we have right now is it's negative. So you need to find a coterminal angle that's positive. Coterminal. So the way you do that is you just add 360 to this, or you could just look at your unit circle and kind of see the symmetry. So adding 360, but we're in radians, so you would have to add 2 pi, would give us, instead of doing 2 pi, I'm going to write 8 pi over 4. It's still 2, it's just I needed a common denominator. So this gives us 1 pi over 4. So this is actually the angle that I'm going to use. It's the same spot, it's just now it's positive. Now I can find it on the unit circle. So for x, -6 times the cosine of positive pi over 4. So this will be -6 times, this is square root of 2 over 2. Now 6 over 2 does not cancel, but it does simplify. 6 divided by 2 would just be 3. So this would be -3 square root of 2. Now for y, -6 times sine of pi over 4. So it'd be -6 times, it's also square root of 2 over 2. So since we did this already, I already know that's going to be -3 square root of 2. So our rectangular coordinate is -3 square root of 2, comma, -3 square root of 2. Okay, this next section, they want us to go in the other direction, convert each set of rectangular coordinates into polar coordinates. So here, they are already in xy. We want to convert it to r theta. So again, each letter has its own little equation to go with it to solve. So r is equal to the square root of x squared plus y squared. And theta is tan inverse of y over x. Okay, so for this one, because we're converting into polar coordinates are not unique. So we might get a few different answers. Just stick with the first one that comes up, so it's always going to be positive. The other thing is you need to make sure that you're in the correct quadrant of the graph. So that's where I'm going to start. If I have a negative and negative, this is in quadrant 3. So that's going to come up later. All right, so let's start with r. So square root of negative square root of 2 squared plus another negative square root of 2 squared. This would be just 2 plus 2, which gives me square root of 4, which just gives me square root of 2. Okay, so that's the first thing. Now we need to still find theta. So theta equals tan inverse of negative square root of 2 over negative square root of 2. I'm going to type this into my calculator, and for now I'm going to use degree mode and then just convert it into radian later. So when I type this in and I put it in degrees, this gives me 45 degrees. So I'm just going to check something. I know that I need to be in quadrant 3. Does the angle 45 make sense? So here's my, coordinate plane. When I have my degrees, it's 0, 90, 180, 270. I know that my angle needs to be somewhere down here, quadrant 3. But 45 is up here. That is not the correct quadrant. So we actually need it to be down here. So to fix that, just add 180 to it, and that gives us 225, and that's in the correct quadrant. Now that 225, I want it to be in radian. When you have polar coordinates, it's pretty much in radian the entire time. So that's the same thing as 5 pi over 4. Okay, so now we just got to put it together. If this is r and this is theta, then our polar coordinate is 2, 5 pi over 4. Okay, let's do another one for practice. So again, first I would see what quadrant we're working with. So this is negative, positive. So if I have a negative x and a positive y, that would be quadrant 2. Let's start by finding r. Square root of negative 5 halves squared plus 5 square root of 3 squared. Now I know fractions seem a little bit more difficult, but I promise they're not too bad. When you're squaring a fraction, you just got to square the numerator and the denominator separately. So 5 squared is 25, 2 squared is 4. So that first one is 25 over 4. Then the next one, also going to be over 4 because of that 2. 2 squared is 4. Up here it's a little bit more steps, but you have to do 5 squared is 25, square root of 3 squared is 3, then multiply them. 25 times 3 is 75. Add those together, they already have a common denominator, so it'd be 100 over 4, which is just 25, and the square root of 25 is 5. So r is 5. Now to find theta, tan inverse of y over x. So 5 square root of 3 over 2, and then over negative 5 over 2. So just type it into your calculator like that. You don't have to simplify or anything. Your calculator is smart enough to do that for you. And I get negative 60 degrees. So kind of another problem. Negative 60 is in quadrant 4. So like this. So if we were going negative, it would be 0, negative 90, negative 180, negative 270. So negative 60 is about over here. We said that our coordinate needed to be in quadrant 2. So same thing is happening here where we need to add 180. That way we can make sure that we end up in the quadrant that we needed it to be. So if I add 180, this gives me positive 120, which is exactly what I need. It's in quadrant 2. Now 120 degrees, if you convert that to radian, is 2 pi over 3. So now if we have our r and we have our theta, just put them together. Our polar coordinate is 5, 2 pi over 3. Okay, so those were just for coordinates. Now I want to convert some equations. So this one, it's polar already. They want us to convert it into rectangular. So see how it has r and theta? I want to switch it around to where it has x and y. So these same little equations that we used up here for r and theta, and then for x and y, those come in handy here when you're converting equations as well. So I want that r, this one here, to become r squared because I know that r squared is equal to x squared plus y squared. So how could I make that r become squared? Well, let's multiply both sides by r. Then that gives me r squared is equal to negative 6r times cosine theta. Okay, now I can replace this r squared, I can replace it with x squared y squared. And not only that, so I saw my negative 6, but r times cosine theta, I'm going to show you up here, r cosine theta is just x, so I can replace that with an x. Okay, so I want all my x's to be on the same side, so we're going to add 6x to both sides. That gives me x squared plus 6x, I'm going to leave a blank here, plus y squared equals 0. So why did I leave that blank? Because this is a circle. It is a circle equation, so we're going to need to complete the square. The special formula for that is b over 2 squared, where b is the number in front of x. So 6 divided by 2 is 3, and then squared is 9. So I need to add 9 here. But what we do to one side, we have to do to the other, just to keep everything equal. But now we can factor this. It's going to be something squared. We just got to figure out what that is. So what number, when I add it to itself, gives me 6, but when I multiply it by itself, gives me 9? The shortcut is just to follow this right here before you square it. So 6 divided by 2 is 3. So the plus 3 should work, and you can test it out for yourself. 3 plus 3 is 6. 3 times 3 is 9. So there is my circle equation. That is the equation that they are looking for. Okay, but now I want to go in the other order. This equation is already a circle. I want to make this into rectangular form. I know that up here, x equals this and y equals this. So I'm going to go ahead and replace them. So r cosine theta, square that, plus r sine theta, square that, equals 144. Now I don't want these parentheses here, so I'm going to go ahead and square anything that's in the parentheses. So r squared cosine squared, same thing for the other one, r squared sine squared, equals 144. And then from here, I notice that they both have r squared, so why don't I just pull that out front? Okay, so here's where our previous units come in. this thing that I have in parentheses, that is a trigonometric identity. Cosine squared plus sine squared, that just equals 1. So if it equals 1, I don't really even have to write it. Now I'm down to r squared equals 144. Let's square root both sides. And r equals 12. That is it for that one. Okay, so that was converting equations and coordinates. Now it says find the distance between the two polar coordinates round to the nearest hundredth. So they're both r theta. So r theta, r theta. But this is the first point and this is the second point. So we're going to do sub 1 and sub 2. Our formula here is r1 squared plus r2 squared minus 2 times r1 times r2 times cosine of theta 2 minus theta 1. And that whole thing is underneath the square root. So notice that it's always r1, r2, 1, 2, but then when it gets to theta, it's 2 minus 1. That's important. So we're just going to fill this in. So I would have negative 2 squared plus 2 squared minus 2 times negative 2 times positive 2 times cosine of 7 pi over 4 minus negative, so see this negative here, minus negative 5 pi over 12. That whole thing has to be underneath the square root. So if you want to, you can change that minus negative into a plus sign because that's exactly what's going to happen. Or you can just type it like this. Your calculator is smart. It can do it. Just a little bit of a heads up. You have to look at the way your angles are being measured. These are radians. So when you type this into your calculator, make sure that it is in radian mode. Okay, so give me a second to type this in and let me give you an answer. Okay, I get, when I type this in, 3.86. So that would be the distance between those two polar coordinates. Okay, let's look at the other side. Okay, now we're going back into parametric equations. Parametric equations, since it says pair means 2, it's going to have 2 equations, one for x and one for y. So what you do here when you want to write it in rectangular form is you eliminate the parameter. So basically, if you look at those equations, they have t in them. I don't want that t. So how do we get rid of it? Well, we're going to solve one of these equations for t. So I'm just going to do the one on the left. So if I have that x equals the square root of 5t, let's square both sides. And now that leaves me with x squared is equal to 5t. The square root and the square cancel each other out. Now I want t to be by itself, so I'm going to divide both sides by 5. So that'll cancel out here, and I'm left with t equals x squared over 5. Okay, so now that we know what t can equal, look at the other equation, find t, and plug in what we just found. So y equals negative 5, but instead of that t, we're going to plug in x squared over 5, and then over 3. So the cool thing about this one is that these 5s cancel out. So all that's really left is negative x squared over 3, which this is a multiple choice test, so I'm honestly not sure. Your answer could be left in that form. Or another way of writing this is to separate this fraction. So technically there's an invisible 1 right here. So they might write it as y equals negative 1/3 x squared. These are both equivalent. It's just different ways of writing it. Okay, let's look at the one next to it. So this one is a trigonometric one. So this one, you can't as easily eliminate the variable like that. Like we need to eliminate theta here. We're gonna have to use some tricks. So specifically our trigonometric identities. So what I'm gonna do is solve each one for just like cosine. So here there's a 2 in the front. So if I divide by 2, cosine would just be x over 2. And then same thing for this one, I just want it to be regular, so I'm going to divide both sides by 7. Sine theta is y over 7. Okay, so there is a trig identity that we used just a few minutes ago that says cosine squared plus sine squared equals 1. So I'm going to plug it in to that identity. X over 2 squared plus y over 7 squared equals 1. So all that's left is to simplify as much as you can. X squared over 4, so I squared the numerator and the denominator. And in here, y squared over 49, again, just square the numerator and denominator, equals 1. And that's it. This is an ellipse. Okay, and then one last thing that's going to be on the test is projectile motion. So it says a soccer goalie makes a save and then drop kicks the ball down the field. The ball travels at an angle of elevation of 40. I think it was supposed to say degrees. At an initial velocity of 30 feet per second from an initial height of 1.5 feet above the ground. So we have a lot of information in that sentence. So the angle is going to be 40 degrees. Velocity is 30 feet per second. Initial height was 1.5 feet. And we are going to need gravity for sure. It could be either 32 or it could be 9.8. It depends on what you're measuring in. Because we are measuring in feet, we're going to use the 32 feet per second. Okay. So what is the maximum height of the ball? So since we're talking about height, that is going to be the y equation. So if you look through your notes, you'll be able to see an equation format. It's y equals t, your initial velocity, so 30, sine of the angle, so sine 40, then minus 1/2 g, so half of gravity is 16, t squared, plus your initial height. So that equation there will tell me the height of the ball at any given time. Now I want to know the maximum height. So if you picture this, here's the floor. He's kicking the ball, but it's not from the ground. It's a little bit higher up. And then it goes like this, and then eventually it's going to land down. So we want to know what that top part is. We want the max. So what we need to find out is how long did it take to get to that max. That's called the axis of symmetry. It has a very specific formula. It's t equals negative b over 2a. You have to picture a quadratic as being ax squared plus bx plus c. So that's where a, b are coming from here. Okay, so in order to find that time, negative b, now b is going to be the one that's in front of t, so 30 sine 40, over 2a. A is always going to be the one in front of t squared, so negative 16. Now, this is 40 degrees, so make sure that your calculator is in degree mode here. Type this in, and I get that it takes 0.602 seconds. So it doesn't take very long, not even, well, about half a second. That's not what they're asking us for, though. They're asking us the maximum height. What we found is how long it takes to get to the maximum height. But now, to actually find the max height, plug in 0.602 anytime you see t. Okay, so typing this in, I get 7.01 feet. So that's the maximum. It only went 7 feet in the air. Okay, so now the next question. What is the horizontal distance of the ball at its maximum height? So we know that this is a max height of 7.01 feet. They want to know this part. How far did it travel this way? So that's going to be our x equation. Again, this is on your notes. But to find this equation, it's just t times velocity cosine of the angle. So t 30 cosine 40. But we found the time. We know that it takes 0.602 seconds. So we're going to plug that in for t. Then after that, it's just a calculator problem. Make sure you're in degree mode, and I get that it traveled 13.83 feet. Okay, and that's it. That's everything that's going to be on the test. So as you can see, our review is only 10 questions. I believe the test is even shorter than that. But if you have any questions over anything, just let me know.